Good morning, students. Today we shall read the derivatives. Derivatives. We have told you the formula of derivative and the first principles, the chain rule. Suppose the derivative of a functions with respect to another functions can be determined by applications of chain rules. Suppose the function dy by dx is equal to using chain rule with the t parameter dy by dt into dt by dx. Suppose dy by dx can be written as the chain rule as dy by du into du by dv into dv by dw and to dw by dx and so on, like this. So this is a chain process, the chain rule. So the function is in one variable, then we shall find the derivative with respect to another variable, then the chain rule is applicable. Suppose for an example, y is equal to sin log x. We shall find the derivative of y with respect to x. So derivative of y with respect to x, this can be determined dy by dx equal to derivative of sin log x. Since derivative with respect to x can be determined as this, so derivative of d by d log x sin log x into d by dx log x. So this can be written as cos log x. Since the formula to find the derivative of function, derivative of sin x is equal to log x, so derivative of sin log x is equal to cos log x with respect to log x into derivative of log x is equal to 1 by x. This is one process. We shall find this same as another process. This is first method, method 1. Another method 2. Suppose the derivative of dy by dx is equal to derivative of sin log x, derivative of sin, since derivative of sin x is equal to cos x, since so derivative of sin, so log x is treated as x, suppose sin x is equal to cos x, derivative of cos sin log x is equal to cos log x into using chain rule derivative of log x. So this is equal to cos log x into derivative of log x is equal to 1 by x. This is method 2. Then we shall find another method. So method 3. Suppose y is equal to sin log x. Y is equal to sin log x. So putting substitution method, using substitution method we shall find the derivative. Put log x is equal to t, therefore y is equal to sin t. So dy by dx equal to using chain rule dy by dt into dt by dx, which is equal to d by dt into what is value of y is equal to sin t into d by dx t value equal to log x. So derivative of sin t is equal to cos t into log x, derivative of log x with respect to x is equal to 1 by x. So cos or t value equal to log x, cos log x into 1 by x. So there are three methods to find the derivative of y is equal to suppose sin log x. First using this method, second method is equal to by this method, direct method, third method 3 is equal to substitution method. So you can follow one of the methods as a method 1 or method 2 or method 3. Any one method you can use. Suppose it is better to use direct method. Suppose derivative of sin log x is equal to cos log x into derivative of log x. This is a direct method. You can follow this. For an example, another example, suppose the derivative of log tan pi by 4 plus x by 2. So using direct method, suppose this is equal to x. So using derivative of formula of derivative of log x is equal to 1 by x. So derivative of log this is equal to 1 by tan pi by 4 plus x by 2 into using chain rule into derivative of tan pi by 4 plus x by 2. So since this is treated as suppose x, so derivative of tan x is equal to sec square x. Derivative of tan x is equal to sec square x. So derivative of tan pi by 4 plus x by 2 is equal to sec square pi by 4 plus x by 2 is equal to 1 by tan pi by 4 plus x by 2 into sec square pi by 4 plus x by 2 into using chain rule derivative of pi by 4 plus x by 2. Since pi by 4 is a constant, derivative of pi by 4 is equal to 0, derivative of x by 2 is equal to half. So 1 by or sec square pi by 4 plus x by 2 by tan pi by 4 plus x by 2 into pi by 4 derivative 0 plus x by 2 derivative is equal to half. So which is equal to tan square theta is equal to 1 plus sec square theta minus 1. Sec square theta is equal to 1 plus tan square theta, which can be written as 1 plus tan square pi by 4 plus x by 2 by 2 tan pi by 4 plus x by 2. So since there is a formula 2 tan theta by 1 plus tan square theta is equal to sin 2 theta. So 1 plus tan square theta by 2 tan theta is equal to cosec 2 theta. Which is equal to 1 plus tan square this by 2 tan this is equal to cosec 2 into theta. Theta means pi by 4 plus x by 2, which is equal to cos pi by 2 plus x, which cos pi by 2 plus theta, cos nobody plus theta is equal to minus sin এটা হলো cosec theta, এটা হলো cosec pi by 4 plus x by 2, cosec 2 theta, that is equal to cosec pi by, change this, so which is equal to cosec 2 into pi by 4 plus x by 2 is equal to cosec pi by 2 plus x. So cosec pi by 2 plus theta is equal to sec theta, sec x. This is equal to sec x. Cosec pi by 2 plus theta in the second quadrant, this is equal to sec x. Using this you can find, suppose we shall read the inverse trigonometric functions. Derivative of inverse trigonometric functions. We have told you the formulas. Suppose there are 6 derivative of sin inverse x is equal to 1 by root over of 1 minus x square. Derivative of cos inverse x is equal to minus 1 by root over of 1 minus x square. Derivative of tan inverse x is equal to 1 by 1 plus x square, and the derivative of cot inverse x is equal to minus 1 by 1 plus x square, and the derivative of sec inverse x equal to 1 by x modulus into x square minus 1 root over, and a derivative of cosec inverse x equal to minus 1 by x modulus into x square minus 1 root over. Using this formula, we shall find the derivative of inverse trigonometric functions, and using the chain rule, suppose the derivative of sin x is equal to 1 by 1 minus x square root over. Suppose derivative of x is replaced by any functions, suppose e to the x, a to the x, log x, log sin x, cot x, every value can be taken. For an example, I mean over derivative of sin inverse 2x. We have a read that by I have told you that sin inverse derivative of sin inverse x will be 1 by 1 minus x square root over. So derivative of sin inverse, suppose this is x, or using chain rule, direct method. By using direct method, I have told you three methods: by chain rule method, direct method, substitution method. You will follow one of the three above methods. Suppose this is equal to x, so using sin inverse x equal to 1 by root over of 1 minus x square, that is 2x square. Using chain rule, derivative of 2x. So 1 by 1 minus 4x square root over into 2. Suppose another example, derivative of cot inverse root x. So since derivative of cot inverse x is equal to minus 1 by 1 plus x square, so x is replaced by root x. So this is treated as, suppose x, cot inverse x derivative is equal to minus 1 by 1 plus x square, that is root x square. Using chain rule, derivative of root x, that is equal to minus 1 by 1 plus x into root x derivative is equal to 1 by 2 into root x, which is equal to how much? The minus 1 by 2 root x into 1 plus x. This is equal to derivative of inverse trigonometric functions. Suppose we shall take another example. Example third. Suppose the derivative of sin x, sin inverse x whole to the power 15. This is in your exercise. Suppose this is treated as x. Suppose using chain rule, x to the power n formula. There is a formula x to the power n, you will n into x to the power n minus 1. So derivative of x sin inverse x equal to how much? Now 15 into x sin inverse x whole to the power 14 into by chain rule into x sin inverse x. This is the product formula. The x is equal to first function, sin inverse is equal to second function, that is u into v formula. First function in derivative of second plus second function in derivative of first. So this is equal to how much? 15 x sin inverse x power hala 14 into by using u into v formula, x into derivative of sin inverse x plus sin inverse x into derivative of x, which is equal to 15 x sin inverse x to the power 14, which is into x derivative of sin inverse x is equal to 1 by 1 minus x square root over plus sin inverse x. This is the answer. So this is the inverse trigonometric functions. Suppose then by derivative we shall find the derivative of a functions by proper substitution, by trigonometric substitutions. Derivatives by proper substitution. Derivative by proper substitution method. Derivative by proper substitution method. We shall thank you all. Now next class we shall read the derivative by proper substitution methods.